All right, so lesson number 20 is multiplying binomials. So we're learning how to multiply two binomials together. And Patrick's question was, what is a binomial? So an example of a binomial would be like x minus 4, because it's got two terms. And we're going to learn how to multiply two of them together. Okay? That's what we're going to learn how to do. We're learning to convert a quadratic function from vertex form into standard form. Okay? In grade 9, we learned how to multiply polynomials by monomials. And you remember that was using the distributive property, everybody's favorite property. Remember you had to multiply the 2 by the x and the 2 by the positive 4. Remember that? Probably first or second week of grade 9. And then multiply the 2x by each term inside the brackets. So 2x times x is 2x squared. That was one of the hard things you had to remember. And then 2x times positive 4x is positive 8x. So try this one. What do we think if you use a distributive property there? What would you get? Too easy or too hard? Yeah?
12x squared minus 15.
Yes. Excellent. Okay, so x times x is x squared. That's why it says remember the exponent laws there. X times x is x squared. Okay. All right, simplify by expanding using the distributive property and then collect like terms if necessary. So the first two, just try using the distributive property, remembering back to grade 9. So 3x times 2x is 6x squared. And then don't write your sign down until you know if it's positive or negative. 3x times positive 5 is positive 15x. Okay, this x is what people forgot in grade 9. Okay? Negative 2x times positive 6x is negative 12x squared. Don't write a sign down. Negative 2x times negative 4. Negative times negative is positive 8x. Okay? So now we're going to use the distributive property, but also we're going to have to simplify by collecting like terms, so it's going to be a two-step one. So first thing you do is use the distributive property. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Then negative 2x times 3x is negative 6x squared. And then negative 2x times negative 1 is positive 2x. Okay? And then it goes to like terms, way back in grade 9 again. X squared ending to be underlined in one color or a certain type of underlining. And then plain X endings, a different kind of underlining or a different color. And then you can collect them. So 3x squared subtract 6x squared is negative 3x squared. And negative 15x plus 2x is negative 13x. So based on that one, try the next one. So your first step is to expand, and your second step is to simplify. Okay, who thinks they have the first line here? Parker. Yep. 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 Yes. Okay, so check your first line and see if you have it right. Okay, make sure you do the right signs, whether you have x squared or x. Okay, so now you're looking for like terms. X squared ending, including the sign. And then we've got our just plain x ending. And that gives us 8x squared minus 5x squared is 3x squared. Negative 20x minus 3x is negative 23x. Do you have one there? All right, so that's grade 9 algebra. Now we're going to add a layer. So in grade 10, we're going to learn how to multiply two binomials together. To multiply two binomials together, you multiply each term in the first binomial by each term in the second binomial, and then collect like terms if it's possible. Okay? So the way I like to, the process is often called FOIL, and it stands for firsts. So here's the first being multiplied together. O stands for outers. Outers multiplying together. I stands for inside. So the inside ones get multiplied together. And L stands for the last. So the last get multiplied together. So each term in the first bracket is multiplied by each term in the second bracket. So there's 4 multiplications that have to happen there. Okay? And if you use FOIL, then you keep track of them properly. So the first 2x times 3x, 6x squared. The outsides, 2x times positive 7, plus 14x, good. The insides, positive 5 times 3x, positive 15x. The lasts, positive 5 times positive 7, positive 35. Now, if you look at it, is there any like term that also has an x squared ending? No. But there is 2 terms that have a plain x ending. Agreed? And then just 1 term that has a plain number. So our final answer is going to have 3 terms, 6x squared plus 29x plus 35. Okay? So we've got 5 minutes. We'll try 2 or 3 more until the bell, and then we'll just continue on after lunch. So remember, your firsts get multiplied together, your outsides, your insides, and your lasts. Put an equal sign at the left and see if you can figure out the 4 terms if you multiply. Each term in the first bracket by each term in the second bracket by your 4 terms. So my first x times x squared, everybody. My outers outsides, x times positive 5 is positive 5x. My insides, positive 2 times x is positive 2x. And my lasts, positive 2 times positive 5 is positive 10. So that should be your first line. Okay, that's the 4 multiplications. And then your only like terms are the positive 5x and the positive 2x that you can combine. So you end up getting x squared plus 7x plus 10. Okay, here we have to watch the sign. But you're still going to multiply the first together. Outers, inners, and that negative is attached to the 2. And lasts. So 4 multiplications. What was your first 4 multiplications? Does anyone think they know them? All 4? Parker? Yep. Yep. Very good. Okay, so make sure you have the minus 2x and the minus 8. And then these are our like terms. So when you combine the middle terms, you're going to end up with x squared plus 2x, because plus 4 minus 2 is positive 2, minus 8. Okay? You want to do one more, or do you want to stop there? One more? Okay, let's do one more. We'll have one less to do after lunch. 4 multiplications. Okay, so the first multiplication is 3x times x is 3x squared. Outers, negative 15x. Inside, negative 7x. Outside, positive 35, because it's a negative times a negative. Those are your like terms. So you end up getting 3x squared minus 22x plus 35. Enjoy lunch. Again, we are learning how to multiply 2 binomials together. And the way you do it is you multiply each term in the first binomial by each in the second, using the distributive property and the acronym FOIL stands for firsts, outsides, insides, and lasts. That's the order you do them in. So first, 3x times 3x is 9x squared. Outsides, 3x times negative 4, negative 12x. Insides, positive 1 times 3x, positive 3x. Last, positive 1 times negative 4, be careful, negative 4. And then you should have like terms in the middle. They both have an x ending, so you can simplify it one more step to give you 9x squared minus 9x, because negative 12 plus 3 is negative 9, minus 4. So a common error would be to write minus 15x there by accident, but remember it's negative 12 plus 3. Okay, try the next 2. I'll just pause it. So first, outside, inside, last. 2x times x is 2x squared. 2x times positive 1 is positive 2x. Negative 1 times x is negative 1x, or just negative x. Negative 1 times positive 1 is negative 1, so that should have been your first line. And then when you combine the middle terms, because they're like terms, you'd end up getting 2x squared plus x minus 1. Okay? Firsts, outers, insides, last. 2x times 3x is 6x squared. That's this one. Outsides, 2x times positive 4 is positive 8x. Insides, negative 3 times 3x is negative 9x. And the last, negative 3 times positive 4 is negative 12. So be careful about the signs. And then positive 8x minus 9x is negative 1x, so you can just write negative x minus 12. Okay? All right, now we've got a little bit of a different one. We've got a number in front. So if you multiply just any three numbers together, does it matter which order you multiply them in? So in other words, I could do 6 times 4 and get 24. Or I could do 2 times 12 and get 24 as well. Right? Or even if I wanted, I could do 2 times 4 is 8, times 3 is 24. So the order I multiply them in doesn't matter. So what we want to do is keep the 2 out front and multiply the binomials together first, and then at the end do the 2. Okay, so you're going to keep the 2 written down, and then open a bracket, and then you're going to do the double distributive property or FOIL. So x times x is x squared. X times negative 1 is negative 1x, or just negative x. Negative 4 times x is negative 4x. And negative 4 times negative 1 is positive 4. And then simplify inside the brackets if you can. And you can, because you have like terms. Careful, minus 1 minus 4 is minus 5x. And then your last step would be to distribute the 2 by each term inside the bracket. Okay? Which ends up giving you 2x squared minus 10x plus 8. So using that for a model, try to do the next one, the negative 3 one, okay? So you put your equals and then your negative 3, start a bracket, and x times x is x squared. X times negative 3 is negative 3x. Positive 1 times x is positive 1x, or just positive x. Positive 1 times negative 3 is negative 3. Okay, so that should be your first line. Then your next one would be to collect the like terms inside of here. So negative 3 plus 1 is negative 2x. And then your last step is to multiply the negative 3, distribute it over everything inside the bracket. Careful of signs. So that should give you negative 3x squared plus 6x plus 9. Okay? All right, now half makes us sometimes a little more uncomfortable, but it's still okay. Still going to do the same thing. So keep the half out front, and then do multiplying the binomials. X times x is x squared. X times positive 6, positive 6x. Negative 4 times x, negative 4x. Negative 4 times 6, negative 24. Like terms. Positive 2x because it's positive 6 minus 4. Distribute. So half times x squared is just a half x squared, okay? A half times 2x though, a half, actually, a half times 2x. So the 2x is really, out of 1 you can think of it. Multiply the tops together, bottoms together, reduce, and you just get x. Because 2 divided by 2 is 1. Or you can think of what's a half of 2x? 1x. Okay? And by the same logic, what's a half of negative 24? Negative 12. Or you can still do the half times negative 24 over 1. Multiply the tops together, the bottoms together, and divide. Either way, you're going to get negative 12. Okay? All right, so that will help us later when we get back from the break, but this is the part that's really important for today, is we want to apply this reasoning to expand and simplify the square of a binomial, which you can see kind of looks like the x part of the vertex, okay? So a lot of people mistakenly believe that that is equal to x squared plus 4, okay? They just look at it and they think, okay, square the x, square the negative 2, I get x squared plus 4. But that's not what it is, because x minus 2 to the power of 2 actually means you multiply it by itself. That's what a power means. You multiply it by itself, in this case, 2 times. And if you multiply this by itself 2 times, there's 4 multiplications that happen, not just 2. Does everyone agree? So you have to do these and these. So you're going to get x times x is x squared, so far that would hold up. X times negative 2 is negative 2x, the outsides. Negative 2 times x is negative 2x again, and negative 2 times negative 2 is positive 4, so that part's okay, but you'd be missing the middle term. Because when you take negative 2 and subtract 2 more, you get negative 4x. Okay? So there's actually 3 terms when you square a binomial, not just 2 terms when you square a binomial. Okay? So try the next one. So you write it out twice, and just do the FOIL or the double distributed property like we've been doing. That's going to take 4 multiplications, not just 2. Check your first line. Yep. Okay. And then you can combine the 6 x's. Okay, so there's 2 more for you to try. Now pause it while you try them. Up to you. So when you square a binomial, you should realize that the middle terms always turn out to be the same as each other. You noticing that? Okay. And then you can collect them. So check your work. 9x squared minus 15x minus 15x again plus 25. Negative times negative is positive. And then collect your middle terms. Negative 15 minus 15 is negative 30x plus 25. Okay, so the reason for us learning this for today was so we could do this. So we could convert from vertex form into standard form. So we could start with vertex form and then rewrite it so it's in standard form. We can go from this to this. Okay? By the end of all quadratics, we'll know how to go between all the different forms. Even though we only know 2 right now, we're going to learn a 3rd form. And by the whole end of quadratics, we'll know how to go between all of them. Okay? So this is our first step. So if we want to convert that, we would write the x plus 2 out twice. So that's just rewriting x plus 2 squared as x plus 2 times x plus 2. But then there's still a minus 5 there. Okay? Then you're going to do the FOIL. So we get x squared plus 2x plus 2x again plus 4 minus 5. And now you've got like terms here, but also here. So your answer should turn out to look like standard form. X squared plus 4x minus 1. So you put it from vertex form into standard form. And they should both have the same a value, so they both have a 1. Yep. And then instead of getting the vertex, which is more graphing friendly, we get the y-intercept, which is -1. Okay? All right, so try these, rewrite each quadratic in standard form. So try the first one. It's pretty similar to the one we just did. And then when the step number is not a 1, it's a little bit trickier. More steps. Y equals x squared minus 8x plus 11? Yes? Everybody good? Okay. The next one is a little bit trickier because of the 2, but we're just going to leave it out front. Then we're gonna write out the x plus 3 twice. And then the minus 7. So that's how you'd start, just writing out the binomial twice, squaring it. Okay? Then this first part of the question is 3 things multiplying together, so you're going to choose to multiply the binomials together first. So you're going to have the y equals 2, leave the 2 up front, and then in the brackets you're going to multiply the x plus 3's together. So x times x is x squared, x times 3 is positive 3x, positive 3 times x is positive 3x, and positive 3 times positive 3 is positive 9. Close your bracket, and then the minus 7 is at the end. Okay? Now you want to see if you can make the bracket simpler. You can, because there's like terms, you can add those. And then you can distribute the 2. Just to the things inside the bracket though. The negative 7 doesn't get multiplied by 2 because it's not in the bracket. And then the very last step is you have to combine the positive 18 and the negative 7. So y equals 2x squared plus 12x plus 11. Okay. Next one's got negative a half out front. So a little bit trickier, I guess. Still going to write the x minus 6 out twice. And you still want to multiply the binomials together first and leave the negative 1/2 out front. Bracket plus 11. Just keep the product in the bracket. Combine these. Then you multiply each thing in the brackets only by negative 1/2. If you're typing it in your calculator, you could do negative 0.5 times negative 12 if that helps you. So when you multiply negative a half by this x squared, you're just going to get negative a half x squared. So when you're figuring out the next one, the coefficient part is negative a half times negative 12, or negative 0.5 times negative 12, which should be positive 6x. Okay, make sure you can do negative 0.5 times negative 12 and get positive 6. Negative 0.5 times positive 36, negative 18, plus 11, and then you gotta combine the negative 18 and the plus 11. That's minus 7. So there's your standard form. So in standard form, all you can tell is the step pattern and the y-intercept. Step pattern is -1/2, which means down 1/2, 1.5, 2.5, and the y-intercept is -7. Okay, it's not a very graphing friendly form. Okay, next one. Because of that negative out front, it's still got those extra steps where you have to multiply the x plus 5's together first and leave the negative out front to distribute later. When you think of a negative distributing, you think of a -1 multiplying each of those things inside the bracket. So it's going to give you negative x squared minus 10x minus 25 plus 18. And then you can combine the -25 and the plus 18. And get -7. Okay, so that's how you convert from vertex form to standard form. So here we have a question where we're given a graph, and we want to write the equation of the parabola in vertex form and in standard form. Okay, so first, from this morning, see if you can figure out how to write it in vertex form. So you need to know A, H, and K, or the vertex and the step number. Everybody likes to do it. So if I'm figuring it out in vertex form, I'm going to find my vertex first. So it's right here. And it's at -1 and 8. Which means that H is -1 and K is 8. Because the vertex is HK. Right? And then I'm going to look for the step number. So when I go over 1, I go down 2. Down 2 is my first step, which should mean that A is -2. Okay? And then check, because then my next step should be over 1, down 6. Yep, down 6. So it works, so my step number is -2. So then I just take the general equation, which is this, and sub in A, H, and K into the proper spots. Okay? So it's going to be y equals -2 bracket x minus -1 bracket squared plus 8. But I would never leave it with minus -1. I would change that to plus 1. So this is vertex form. So we've done that. Now you want to use what we just learned to write it into standard form. So to get it into standard form, we would start by writing out the x plus 1 twice. And then do this FOIL. And then collect the middle terms. I'm excited to compare the y-intercept and see if it works out. Then we distribute the -2 through the bracket only. And then finally you collect the plain numbers. So this should be my standard form. And the standard form should have the same A as the vertex form. Notice that they both have -2 for A. And 6 should be the y-intercept. So check up on the graph and see if the graph touches the y-axis at 6. Here's the y-axis. 1, 2, 3, 4, 5, 6. Yes. Okay. So the y-intercept is the C in standard form. Okay. Y-intercept and vertex are not the same thing. Everybody good? Vertex is where it starts. Either opens up or opens down. Y-intercept is just where it touches the y-axis. You could have your vertex be on the y-axis, and then your y-intercept and your vertex will be the same thing, but that's the only time there. Okay, so success criteria, I can expand and simplify the product of binomials using FOIL. I can square a binomial using FOIL. And I can use FOIL to rewrite the equation of a parabola from vertex into standard. That's our first switch we learned just before the break. We're going to learn 10 days.